OSI model. Hello and welcome to iNurture video. In this video, we will be discussing about OSI model. After watching this video, you will be able to understand what is OSI model, OSI model layers, working of OSI model. Digital revolution has almost changed the way we communicate beyond our reorganization. Different hardware manufacturers use different set of standards for data communication across a network, resulting in several incompatibilities. Therefore, ISO, which is abbreviation for International Organization for Standardization, works on standardization of model. It developed networking model to standardize the process of basic network design and communication. This model is called OSI model. It stands for Open Systems Interconnection. OSI model refers to a standard networking reference model which specifies the process of data communication between two systems in a network. Since rapid growth of computer networks caused compatibility problems, ISO recognized these problems and released the OSI model in 1984. OSI stands for Open Systems Interconnection, and it consists of 7 layers. We will be studying about these layers in detail. The main purpose of designing these layers is to reduce complexity and make standardization easier. Each layer has its own unique function and a specific protocol. The protocol messages in upper layer is data to layer below. Now look at the first layer of the OSI model, that is, physical layer. The physical layer of the OSI model provides information on the physical and electrical specification of the devices used. Physical specification refers to the type of cable used, connectors, length of cable used, etc. Electrical specification refers to the signals used to send data such as the duration of voltages, signal voltage, etc. The primary function of the physical layer is to transmit bits of data in the form of electrical or optical signals on the basis of the communication medium used. For instance, this layer decides the process in which a stream of bits needs to be sent from the data link layer onto the pins for a parallel printer interface. In this layer, hubs and repeaters are the devices that are most often used. Data link layer is the second layer of OSI model. This layer first divides the data frames into bits that are transformed into electronic signals and transmitted over the network. Frame is nothing but a unit of data. At the destination computer, these bits are reassembled into frames so that the upper layers can process them. Data link layer also helps in identifying data corruption. Network layer is the third layer in OSI model. The data is transferred from data link layer to network layer. Network layer provides the route for data transmission from a source to the destination computer. Routes are identified on the basis of the packet addresses and network layout. Each computer in a network is given a unique number. This unique number is usually called as IP address of the computer. At the network layer, IP addresses of a computer are translated into physical addresses such as media access control, MAC addresses for data transmission. At the destination computer, the translation process is reversed. This layer ensures proper measures to control the network traffic. A router is usually used at the network layer. Transport layer is the fourth layer in OSI model. Once the route of the data transmission is decided, the data is transferred from network layer to transport layer. Transport layer provides source-to-destination communication between devices on a network. This layer ensures that the data received by the destination computer is exactly the same as it was sent by the source computer. It ensures that data transmitted over the network is error-free. This layer offers two types of services. One is connection-oriented. This service establishes a virtual connection between two devices before transmitting data, and another is connectionless. This service sends data packets from one device to the other without establishing a virtual connection. Transport layer commonly uses two types of protocol. Let's look at them. Connection-Oriented Transmission Control Protocol (TCP). TCP is a standard that involves establishing and maintaining a network conversation so that the application programs can exchange data. and Connectionless User Datagram Protocol (UDP). UDP sends short messages called datagrams over an Internet Protocol (IP) network. Session layer is the fifth layer of the OSI reference model. It establishes and terminates a connection called a session. This layer enables users to establish sessions between different computers. In case a connection is lost, the session layer helps in restoring the session. After the connection is established by the session layer, presentation layer ensures that the data transfer through it and entering the application layer is in the well-defined and standardized format. Computers in a network have different file systems and file storage formats based on their operating systems. For instance, in Windows operating systems, file systems and storage formats differ from those in the Linux operating systems. Therefore, prior to transmitting data in a network, systems must first agree in terms of the format to be used for transmitting data in the presentation layer. Finally, application layer is the uppermost layer in the OSI reference model. It serves as the interface between the user and the network, and user directly interacts with this layer. It provides services for interacting directly with the user applications. Applications such as Microsoft Word and Microsoft PowerPoint that run on the local computer use an interface provided by the application layer to get network services such as retrieving a file from the network. To easily remember the 7 layers of the OSI model, remember the mnemonic for top to down. All people seem to need data processing. And from bottom to up, please do not throw sausage pizzas away. Here, the first letter of each word of the mnemonic represents the first letter of a layer. To understand how OSI model works, let's take an example. An email has to send from a source to destination. Let's see how it works. In the OSI model, each layer talks to the corresponding layer on the destination mode. This is because each layer appends control information to the data from the layer above and the layer on the node that reads it. Let's see what happens when the client sends an email to the server. We will see layer by layer. Application layer provides the UI to the application programs. In this example, it could be an email client like MS Outlook or a web browser. The protocol that the application layer uses to send commands the server how to handle the data is the SMT protocol. Presentation layer. Here the email will be converted to network format from system-specific format. That is, the text to ASCII and also specifies the format of the image. In addition to that, this layer is responsible in providing encryption and compression. Session layer. In this layer, a header will be added to the email to handle the sessions. This layer is responsible for facilitating the starting, handling, and ending of connections between nodes. Transport layer. In this example, the transport layer uses TC protocol. Here, email is broken into segments that are resembled by the transport layer at the receiver's side. Each of the broken segments are sent to the network layer later on, and also at this layer, the source and destination port will also be specified. This layer is mainly responsible for flow control, fragmentation, port assigning, and reliability. Network layer. This layer provides addressing across the internet and determines the path the data is to be sent. That is, routing happens in this layer. The segments will be given the source and destination IP address, and the segments become packets. The packets will be then passed to the data link layer. Data link layer. Here the packets become frames and physical addresses of the two nodes the email is traveling between will be assigned. Physical layer. The physical layer put the data on the physical medium passed to it by the data link layer. Then the frame will be sent to the router via the LAN, and then the router must send the frame to a different network with a different data link protocol. Here the only modification is needed in the data link layer and the physical layer. The router will remove the data link information and will send it to the network layer, and it will then determine where to send the packet by using the destination IP address. After that, the router encapsulates the data with the proper data link information from the WAN. When the receiver side router receives the data, the router will remove the data link information and will send the packet to the network layer where the next destination will be identified, and once identified, it appends the appropriate date link information to send it to the Ethernet network again. When the data is received at the receiver's side, each layer of the model will remove a layer of encapsulation and reads the information appended by the same layer on the sender side. Now let's see what happens at destination computer. Physical layer reads the bits from the physical medium and will convert them into frames to send the data link layer. Data link layer. Here the date link headers get removed and convert the frames back to packets and will pass to the network layer. Network layer removes the IP header and convert the packets back to segments and pass them to transport layer. Transport layer. As mentioned above, the segments will be reassembled back to the original data and uses the port number to determine the application to send the data. Session layer uses the session information to determine which communication stream the data belongs to. Presentation layer. This layer uses the information passed by the session layer to be able to interpret the data for the specific machine. Application layer. The application will read the SMTP commands that the application layer on the sender sent, and hence email will be received. Let us have quick recap on what we discussed. Rapid growth of computer networks caused compatibility problems. ISO recognized the problem and released the OSI model in 1984. OSI stands for Open Systems Interconnection and consists of 7 layers. The 7 layers are application, presentation layer, session layer, transport layer, network layer, data link layer, physical layer.